kind of a little city. The city has some really aggressive climate goals. So they want to reduce their greenhouse gas emissions 80% by 2050 from 2005 levels. The city organizations are going to set an example by reducing their greenhouse gas emissions 80% by 2030, but that's from 2008 levels for some reason. And then they want to have 100% renewable energy by 2031. I know their infographic says 2030, but it's actually 2031 on their current plan. So to achieve these great goals, they're promoting high performance buildings from commercial all the way to down to residential and throughout the life of the building. So they have commissioning plans and requirements for reporting and a lot of different things. And they're also creating effective and viable codes. So we're going to go through a lot of the tools that the city is providing to make these codes viable and effective. So the current estimate is that the 2017 City of Boulder Energy Conservation Code has the lowest EUI currently in the nation. So the City of Boulder started their energy conservation measures in 2013, where they required 30% more efficient design than IEC 2012, which they correspond, and everyone corresponds to ASHRAE 90.1 2010. So that was pretty vague, and they have since made that more clear, right? 30% more efficient. So some buildings were doing 30% energy savings, some people were doing 30% energy cost savings. They've since moved to cost savings, and that is the metric that they use in the 2017 City of Boulder Energy Conservation Code. So this is their giant table of paths to conformance, and I'll go into residential and commercial separately in a minute. A few things to know is the residential path in 2013 included multifamily, so that's all R groups in the international code. Now in 2012 IECC, residential is defined as single family dwellings, and multifamily dwellings groups R3 and R4. So that does not include multifamily. You would go to commercial if you're doing a multifamily building. Ooh, and this assessed value is an interesting thing. So when you look at any path that has an alteration or repair, it's a % of estimated construction price of the assessed value. So you can get your property assessed and have that. But that % construction value in the March edition of the 2017 code was for permits within the last 24 months as your construction value, because the city really wanted to avoid people phasing their projects to avoid these triggers. They've since removed that because it's kind of a commercial nightmare to have a owner own a building and then the tenants come in and the first tenant gets away without meeting any of the code and the second tenant comes in and gets hit with all of them. So to avoid that, they've removed that. But I think that was an interesting aspect that the city tried to incorporate. So I'm going to start with residential. So we'll just take a minute and kind of walk through this flow chart so you can understand how they're breaking it down. So for new construction, if you're building a tiny home, 500 square feet or less, you only need to meet the mandatory and prescriptive requirements of the code. And then if it's more than 500 square feet, you're going to do mandatory and ERI, which is an energy rating index. That's the non-trademark version of a HERS score. So HERS is trademark, and I'll likely use that score because I think that's more understandable. So that's the residential performance compliance path, is the HERS score. And then if you're doing an addition, again, if it's small in Boulder terms, 1,000 square feet, you'll do the mandatory and prescriptive. Otherwise, you could do the performance path. Alterations and repair, again, that's a % of your construction value from your assessed value. So you can, if you do a lot of renovation or repair, you're going to have to bring your whole building, your whole home up to new construction. I'm going to do a brief highlight of residential mandatory requirements. As a homeowner looking at these, I didn't scoff at any of them. I mean, a programmable thermostat, I hope everyone has one. Air barriers, I don't think anyone's complaining about those. And they do have mandatory requirements if you have some luxury items like a pool or snow melt. They require covers and some different controls. In addition to the City of Boulder Energy Conservation Code, they are requiring solar ready for your residential home, construction waste recycling. So even on just building a home, the city wants that. EV charging. If you have off-street parking for your residents, then you need to provide infrastructure to provide 240-volt EV charging. And then they have reduced flow plumbing fixtures, and that's not anything excessive. But that's another one that affects energy. So the City of Boulder's tools includes lots of checklists. So they have a checklist for the mandatory measures that I highlighted a few of before, and they have one for their prescriptive requirements. So can barely read it there, but they're covering the standard things. They're covering envelope, equipment, pretty straightforward for residential, not too many options there. So this goes into the performance path. So your ERI, your HERS score, the code has that nice language up into the top left, which they translate into this nice graph. So you can see here, if your home is really small, 500 square feet, then you get a little more leeway. And then as your house gets larger, your ERI score goes down all the way to, which is less energy. So if you're a 5,000 square foot home, in 2017, you already need to be net zero. The City of Boulder does define net zero to include purchased renewable energy from approved sources. So if you don't have good solar access, you can purchase that energy. And they also created these tools to help you find your ERI. So the first one on the top right is just for new construction, really straightforward. You put in the square feet, you get an ERI. For your renovations and additions, they have a little more advanced tool down there, but it's also just going to simply give you ERI, so you don't have to interpolate from this chart or read the lovely paragraphs that are in code language. That's all I had on residential. Any questions on that portion? Awesome. Moving right along. So for commercial, it's the same thing, except they're going with cost. So if you're building a small building, low-cost building, less than $500,000, then you only have to meet the mandatory and prescriptive. Very straightforward. But once you go above that, you're going to trigger these performance requirements, which is requiring energy modeling for code compliance. So 30% better still than ASHRAE 90.1 2010 for commercial buildings. So 2013, 2017, the same for this commercial aspect. Alterations and repair, same kind of thing. If you aren't doing more than 26%, mandatory prescriptive, you're doing, 26 to 50, they want you to show performance compliance for that portion, and then 50% or more, you're almost redoing your building, so new construction requirements. So another brief highlight of the mandatory requirements. There is, again, a checklist for the commercial mandatory requirements. They want solar ready. So for commercials, it seems pretty aggressive to me. They want 40% of your roof area to be unobstructed by vents and other equipment. So it doesn't have to be 40% continuous, but it has to be 40%. And then you have to have the structural load accounted for in your original design. You need to have conduit already installed, and you need to have space in your electrical panel. So that's really extensive solar ready requirements. They have air leakage testing. That's a little bit more aggressive than LEED requirements. So they want whole building air testing. That's great. But then if you have a multifamily building, they want testing on 20% of the units. That's just a little bit more than other standards are asking for. And my favorite is the operable window switches. I love to see these. So if you're not familiar with operable opening switches, so this actually applies to doors or windows. So if you have a conditioned space, if a door opens in your office, that's an operable opening, and they want you to have a switch on it to set back or shut off your HVAC when that is open. You get an exception for doors with automatic closure. And like I said, you have to have the control device in your office. So For a typical office building, there's going to be, right, a string of offices with a string of windows, and only one person will have the thermostat. So only that person actually has to have the window switch. So that person opens their window, the HVAC sets back. The person in the next office doesn't open their window, their HVAC still sets back. That's up to the designer, but that's what the code requires. And then there are additional requirements outside of the energy conservation code for the City of Boulder that affect energy, which is more EV charging. So for multifamily that's now commercial, you need to do any off-street parking, you need to have a certain % of EV charging available and reduce flow fixtures. Nothing notable there. So this is a little snip of the commercial prescriptive requirements. This is a lot more extensive. I want to say this is like 9 pages. And these checklists will be filled out by the design team, right? And they're actually going to put those on their construction documents. So that means they're stamping these. So it's pretty serious. It's nice to have someone else review it before you submit, kind of like any construction document going in for permit. So more on documentation. In 2013, they didn't have specific requirements on who was doing the performance analysis, but they could ask for a licensed professional to provide additional information and documentation. Now in 2017, they don't have that licensed professional. They have this registered design professional, and they don't define that. They didn't want to be the ones giving preferential treatment to an ASHRAE standard or professional engineers or anything like that. They're just asking for some kind of registration. So in our office, we have PEs, we have BEMPs, CEMs. There hasn't been any issues with any of those qualifications. And later in 2017, this is a bonus from, if you saw this in Build, they finally created an energy modeling report template. So this is a short 2 or 3 page Word document that has a few tables, some prompts for narrative. Really not extensive as far as the documentation for submitting for permit. They did provide, though, a checklist, which is 2 pages. And their template, interestingly enough, doesn't quite include all of the items on the checklist. So what we've been doing is providing their nice template, just a few pages, and then another additional memo to include some of the additional information that they're asking for. And then the people developing the code at the City of Boulder are former modelers. So they interestingly asked for your errors and warnings report. They do not want your output or input reports. So for OpenStudio, you aren't giving them the HTML files, right? Because you're printing this and giving it to the building department like a document. They don't do electronic yet. This is the building department. So they don't want that giant model files. They want your memo, and then they want this error report, which is kind of extensive. This is just like one example, and I don't find it to be like entirely helpful. They're very repetitive if you're familiar with modeling. And then we're anticipating, doing another little narrative for this to say, hey, we aren't worried about these warnings. These warnings are for not our design if your temperatures are going out of whatever given range your software wants you to be in. So that's what I have on the documentation. Any questions on the documentation? All right.
Did they look through like detailed sections to verify the like R value or U value calculation?
Oh yeah.
So that
Yeah, so in your memo, you're kind of reporting like, hey, this is what I modeled the R value and the respective U value as, and they're really looking through those details. Even for the air barrier requirements, the energy reviewer is looking for those. And I was going to speak of this earlier, but I'll mention it now. For the multifamily project that's in the case studies, they got the initial documents and saw these balconies and were like, oh, we need you to show the explicit D rate of your envelope for these non-thermally broken balconies. So if you can imagine, this is actually a rendering of that building, and you can almost see it there right by the blue box. My mouse on it. There's this balcony that continues with the slab It goes to the exterior, not thermally broken, so they want you to derate, as you rightfully should. So just to be clear on the documentation, the city is not issuing permits for construction until you show compliance with the code. So whether that's the mandatory prescriptive or the performance compliance. So that adds in a little bit of urgency to my models, because usually with lead models, I'm like, you don't need to get your lead certification in next week. But when they're going for a permit, it's like, oh yeah, you really need to get those documents in so the city can review them and you can start construction when you planned. Fraser has a really nice campus in Boulder. They're a nonprofit retirement community. They have facilities from independent living, which is essentially apartments, to a wellness center, to some cafes and restaurants, if you will. Oh, and they have about 400,000 square feet existing already, and then they're adding quite a few additions right now. These are the 3 projects we had with Fraser when I presented for SimBuild. The independent living I've spoken of, it's about 100 units with some community spaces like most apartment buildings have, the entry lobby, some corridors and little reading spaces. And they have a first level parking garage. And they're doing, in addition to their arts and education building, which is an auditorium. And then they have a garden level support offices, right? So it's a nonprofit, so they have people that work there. So they have support offices and a movie theater for the residents in the garden level. And then they're doing an addition to their wellness building. So since this presentation at SimBuild, the remodel is going to be broken out into 2 different projects. So this is a rendering of schematic design of the wellness building. So the wellness addition will be that part with the X's on the roof, and then the remodel of that Fraser Central will be one project, and they'll actually do another one for some support offices they're calling marketing. So pretty good breadth of project types. Oh, and we have another remodel with them that's going, for a meeting room. So it's like, kind of like this. You're going to eat in there. They have a little place for caterers. This is a brief site plan. You can see the new independent living building. They have a new cafe project, which is connected to the existing arts and education and wellness. That star is indicating their central plant. So this facility is open since 1960. So they have a mixed central plant, as you can imagine. Their boilers average about 79% efficiency. And then throughout the campus, they have air-cooled chillers on different rooftops for the different buildings, and one building with a water-cooled chiller, a cooling tower, and actually a water-side economizer heat exchanger. So they have quite a bit going on around their campus. So now that you know what the code's doing and the projects that we have, I can talk about our compliance modeling workflow. So Fraser is an interesting case study because they actually put in a site plan just before the March 2017 start of the 2017 code. So actually, all of those projects I mentioned are grandfathered into the 2013 code. So the biggest difference for Fraser, besides all those extensive mandatory requirements, their projects won't have to do the mandatory solar ready or EV charging or anything like that. So that's a big save for them, is that for the 2013 code, like I mentioned, the multifamily buildings were considered commercial, but they had a reduced percent savings. So it's only 14% energy cost savings required for their multifamily building. We started all these projects in schematic design and early phase modeling, where people like final results from preliminary information and we start estimating how much PV is required to meet the energy requirements or goals. So can't get away from talking about early phase modeling without tools. So We prefer to use the same tool in early phase modeling as the detailed building energy model, or the model we're submitting for compliance. So the initial model, while it's schematic, might be blocked, we might throw it away. We find that we aren't throwing away everything. You need to keep your schedules, you need to keep your space types, your plug load values, and that really, keeps it more consistent when you're trying to get good results and help the design team decide how much PV or what ECMs they really need to incorporate. Anyone want to talk more about design tools, early phase energy modeling? Awesome. So submitting for code compliance, we really wanted to use reputable guidelines and references. So these are all your standard. We do use the independent living residential building is going for LEED V4 for homes. So we did use for homes multi. Favorite white papers is this. Can everyone online hear me? All right. All right, so I was just about to highlight one of my favorite white papers because I'm a nerd. Okay, so my favorite reference for elevators, since I don't like scouring through the plans to find out if it's a hydraulic lift and how many horsepower those are. This white paper is a great tool because you get to put in the square feet, the number of elevators, and the number of floors, and it just gives you your annual KWH, so you can use whichever schedule you want. So if there's anything like that I think is like a little ad, it would be that one. I don't know if anyone else uses that. And then as I mentioned earlier, for multifamily, the city specifically asked for derating using the New Building Institute's multifamily guide. So you don't need to be derate for your outside corners and your roof to wall intersections for commercial buildings. And we clarified that with them. If you have balconies or something special, then yes. But it's really on these multifamily buildings where they want you to derate for those balconies and those special cases as you would for commercial. But then for residential, because it tends to be more envelope heavy, to derate for those connections. So this is my version of that table for the residential building for Fraser specifically. So here is the model for independent living. So for early phase modeling, the model looked much like this because one of the biggest questions was, can we meet the 14% energy cost savings requirement with the windows we had? And early phase modeling said yes. With the ECMs you have planned in your design, you can keep all your windows and still meet 14%. That did not turn out. They were just under 14%. There's one thing I did not take into account in early design is this interesting multifamily thing. I don't know if anyone's familiar with it, where they want the residents to buy some lighting fixtures. So when they move in, that space doesn't have a lighting power density plan for it. So you can't take any credit for it. And I was like, oh, I want credit for that. But we can't take it because they don't have it designed. But the window to wall ratio isn't aggressive, 26%. The independent living is not connected to their old central plant. So that's a benefit to them. And they have new air cooled, yeah. Yes. Yeah, and so I don't know if you're familiar with the baseline. So this would be my proposed, and north would be north. And then my baseline per ASHRAE 90.1 appendix G requires that you rotate your baseline 4 degrees, or all 4 orientations. So if you have the optimal orientation, you're going to get some credit for that. But yeah, when we build this up, we put it at the right angle, or you can adjust it in the software afterwards. Yeah, so they have the new system. They have combined condensing natural gas-fired boilers that do domestic heating and space heating. And then one of the roughest additions for me, and what our commissioning guys always harp on is these multifamily plenum spaces, if you will. So in their parking garage that's on the ground level, they put all the pipes. And they don't want the pipes to freeze where in climate zone 5B it gets cold. It's an unconditioned garage, naturally ventilated. So they put like drop ceilings around them, and then they put electric unit heaters in there. So I was like, this is like, the commissioning guys are like, these use a ton of energy, like they don't put the ceiling tiles back. And so I'm like, oh, I'm all worried about it. And I put it in the model. And in the simulation, it doesn't use that much heat, right? They're like heating it to 40 degrees. I can't justify modeling that they didn't put the ceiling tiles back and then it's completely open. So it wasn't as bad as I thought, but that is an interesting electric heat use in this building, and that you might run into in your multifamily projects. We can pull the reports up for any of these if you want more specifics on any of the projects. This is where the independent living building is now. So they got 11% energy cost savings from 2010. I think that's pretty good, not getting all the lighting savings. And then they have 1% PV, which turns out to about 16 kW. So I think this is a pretty normal flow of energy consumption for a multifamily building. Nothing too interesting report there. This is one of the City of Boulder's tables filled out for the independent living building. So some really heavy data from modeling that I'm sure you guys are familiar with. You know, how much electric versus gas cost. And then we have our PV down at the bottom. Don't need to read that for you guys. So the arts and education addition. So this is a giant auditorium. And this is the original schematic design plan where they had the addition and a remodel of that space with a very large shade in the front. And the final design right now, construction documents are going with this top right design where, you know, the other building is just a shade. And they have a nice atrium and some daylighting there. So this is interesting enough, also 26% window to wall ratio. They have a pretty good envelope here, and the main auditorium space gets new rooftop units that have energy recovery ventilators and outside air economizer, vent control ventilation. So this project is very nearly meeting the 30% energy cost savings by itself, really taking advantage of that occupancy use type. So you can see energy cost savings is nearly 30%. And if they weren't already providing PV on their campus, I think they would do some more ECMs to get that last percent of PV. An interesting aspect of this project has been going through value engineering. So for energy modeling, like each value engineering change they make is going to make a change to your model. Yet you have to go into construction documents. So luckily they are doing a good job with energy savings. So some of the items that are undecided yet are actually they're getting no credit for. So it's for some of the offices, they don't get any energy savings in those spaces. The wellness addition. So this project is currently a little bit on hold. It's just going to be this addition there, that new space where they're going to house some pools. We already have some weightlifting physical therapy rooms for the retirement community. So I learned a lot more about pool covers than anyone would want to know. If you were wondering, ASHRAE 90.1 2010 requires pool covers for it to be a vapor barrier if the pool is heated to 90 degrees or less. So pool covers are a very contentious thing as they take up space. So now they're actually making, and Fraser I think is intending to use this chemical-based pool cover. So this chemical you feed into the pool and it covers the surface like a pool cover, because The code just wants a vapor barrier, right? So you aren't like losing all that heat and water to evaporation. So this chemical takes the place of that physical cover that someone would have to unroll and roll, unroll and roll. And they will get new rooftop units for the pool area because it's a very specialty use type. Any of the other spaces will use the existing central plant with banquets. Yeah. Yeah.
Leave that in all day, all time, people swimming and drinking.
Yeah. Yeah, when you look at the site of this. Yeah, so on the site, I had to look it up when I was like, does this meet it? They have a nice picture of a kid and a dog in the pool. So, yeah, that's a great question. So in 2010 ASHRAE, they are. In 2015 IECC, they are different. And they have a therapy pool, which the pool designer assures me is only going to be heated to 90 degrees. So they don't have to do, if you go above 90 degrees of your pool, then you have to provide an insulating cover as well. It needs to be vapor retardant and provide insulation. Yeah, we can talk about the rooftop units. For Climate Zone 5B for pools, we typically dehumidify with outside air, right? Our air is typically dry and there's not a lot of concern with that. It's great to have some fresh air. So one exception to putting on a pool cover, vapor, liquid, whatever, is if you recover 70% of your heat on site. So actually in Boulder, we're seeing pools heated with solar thermal, so they don't have to put on a cover. This project didn't want to do solar thermal for some reason. I mean, it's a long payback for them, so I understand. But you can use the rooftop units that also do the energy recovery. But like I mentioned, if you're using outside air to dehumidify, then you aren't going to get even close to that 70% requirement. All right, so we don't have savings on wellness yet because we don't know where it's going to land. But you can see the interior equipment load is dominant because that's where I put the pools. Their process load, the baseline is going to suffer from all that heating consumption as well. So this is more of the changes that happened as the design went along. The yellow is the original wellness edition and a little bit of remodel. And then the blue is the new. So the top one would be wellness, and that bottom blue outline is going to be renovation. That'll be submitted as a completely separate project. And I'm proposing that they do 2017 code for the renovation. So if you remember, I mentioned that Fraser got the grandfathered into the 2013 code for all these projects that were approved on their site plan, which said that all commercial renovations and new construction have to be 30% better than ASHRAE 90.1, 2010. So that would apply to this remodel. But if the remodel goes to 2017, it has to be more than 26% of the assessed value of very extensive real estate in Boulder to trigger that. So they would only have to meet prescriptive and mandatory requirements. So that is an advantage of using the 2017 versus the 2013. Where in 2013, if it's over 200 or 20,000 square feet, they just have to do the model. There isn't any exceptions. But in 2017, they can get around that and not have to do another performance model. Oh, and changes. More about the changes. PV, right? So we originally estimated that this project would probably need about 20 kW, right? That they had a lot of ECMs in their design, but with some value engineering, we're up to 90 kW. So that's a big change, a lot more PV. So really monitoring those changes, and in my experience, design teams like to see the iterative. So even if they give you, schematic design and you're like, oh yeah, 20 kW, and then they go to, 60% CD, they want to see the mechanical changes versus the lighting changes versus the envelope changes. So if you can bundle those together as you're updating your model instead of just updating everything in your model and being like 70 kW, it's going to make them feel a lot more included and less shocked by the changes that I think most simulators are used to seeing, but design teams don't recognize all those little changes, especially the architect or the owner that is not looking at necessarily the mechanical or the lighting plans all the time and recognizing those changes. And this is our ideal, my ideal project progression. We have the baseline, which would stay the same, but it doesn't always, right? People switch fuels, add crack units, and the baseline changes. And then you have your initial design where they have some energy savings, and then your construction documents where you help them save all this energy, and they're very nearly to the requirement with just their great design. No. So it wasn't clear. That's what I would really like to see, and that's what we're striving for. All of those projects, besides wellness that are on hold, are into the city for review comments. So I don't have specific review comments for you, but they are out there and the city is looking at them. And they are all taking PV to get to their requirements. So that's where we're at. That's all I have planned. I can get to any specifics if you'd like. We do baseline modeling with OpenStudio. The City of Boulder is in Xcel Energy's territory, so they do some rebates for energy design assistance through modeling. So that's one benefit and one large reason why we use OpenStudio in-house. And we haven't looked at using CBEC-COM for other forms of submittals outside of California. Have you had experience with using them for other?
No.
Okay. Mm-hmm. Yeah, and I think that'd be great. I know we've used sometimes CBEC-COM for the envelope calculations. I think that is a very trusted, reliable way to build an assembly and show that you're modeling it accurately. So we do that, but we don't use the whole workflow. Yeah.
But the city code that was established, about a little bit of background on how they got there. That from all the city, were you guys involved with helping them kind of figure out where that needed to be and what the requirements ended up being, or back a little bit back on how it got there?
Okay, yeah. So they got their starting right in 2013, where they started just saying like, we want to get to net zero energy by 2031 or 100% renewable by 2031. So that's their trajectory. That's what helped them. And the City of Boulder does want to be more progressive. So when they modeled that for 2017 and saw that they were the most aggressive in the nation, they were like, oh, let's wait here and wait for everyone else to catch up, right? 2030 is kind of rapidly approaching in as far as codes and standards adoption world. But they didn't push it further in 2017 from their 2013 requirements based on that. Is that? Ooh. Another fun thing about Boulder in their goals is they actually want 90% solid waste diversion by 2030. So they have a mandatory composting requirement. So our office in Boulder has composting there. I think we're going to see it a lot more in restaurants and things because residentially it's required for all the haulers to provide compost bins. So a lot going on in Boulder. Yeah. Mm-hmm. Yeah, so one of the biggest pushbacks was the original 2017 update that had this construction value for the 24-month permits. There was so much pushback that they actually did amend that from the March printing to the October printing. So that's no longer a requirement. That was a big pushback. I think there's also some for the remodels and renovations. There's a lot of concern around large repairs, like replacing a whole roof on old buildings. So they're really looking at the alterations and repairs. I think that's where they're seeing a lot of pushback. But the City of Boulder is standing pretty strong as far as we have aggressive energy goals, and Boulder is growing, so they if someone doesn't want to build there, there's someone else that will, luckily. Yeah. Mm-hmm. Yeah, and I think that they might use the disclaimer that this is performance compliance. Besides those mandatory requirements, which aren't too aggressive besides solar ready, that they can prescriptively meet it however they want, and so they could hopefully find more cost-effective ways to meet that. So, yeah. Yeah, there definitely is. So I mentioned that, right, the city contacted us and was like, hey, we're looking at the architectural plans and we want you to show this duration. So they're definitely, and if you go to boulderenergycode.com, you can download the whole 2017 code, as well as they have a contact through the city that is their liaison that's there to answer all your energy modeling questions. Well, not all your energy modeling questions, all of your project specific questions. So especially when I'm talking about renovations and things where you're trying to follow this mandatory and prescriptive, you're like, well, when is this prescriptive or mandatory measure triggered with a renovation? Because Fraser is adding, some cladding to one of their buildings to, do a little facelift on it. So do they have to update their entire envelope to, the mandatory requirement measures? And the answer is yes, if they're penetrating the cavity. So since they're removing the old cladding first, they're penetrating that cavity, and then that therefore triggers them to have to add additional insulation to this remodeled portion, which seems a little odd because it's a small remodeled portion. But then if they keep doing that across the building, the hope is of the city that eventually the entire building will be brought up to the standard.
Have you heard of any other jurisdictions or cities becoming inspired and putting a similar stance or similar format to this?
I have not seen performance requirements by other cities yet. No, I'm hoping other people will get inspired. Mm-hmm. Yeah. Mm-hmm. Yeah.
You mentioned like the design system, what's available from utility.
Mm-hmm.
And provide a little bit of detail around what qualifies for that, when you say max, or just a little bit of background detail around that.
Okay.
And then on the sprinkler projects, are they also getting utility incentives for doing some of this progressive stuff? This one in my head, we have a very rigorous code, and utility only pays the stuff that's better than that. I mean, that's not true, I know, but that's what I assume. So there's not a lot left on the table to potentially incent beyond that really rigorous stuff.
Yeah, so you're precisely right. I'll start with the second question first. The utility does not incentivize anything code or below, right? So since the City of Boulder has this really aggressive code, you have to do things above and beyond that to get the incentive. The Xcel Energy's incentive program, I don't have the caps off the top of my head, what they do, but they do provide design team assistance. So it's not just for the energy model, it's for the rest of the design team, as well as the owner gets some incentive there. The renewable energy does not actually get included in that either. So the utility treats, energy conserving measures and good design in this energy design assistance modeling program, and then your PV would be in a completely separate bucket. Yeah. That get filled each year. It's very sunny. Well, great. I will hang out afterwards if anyone has additional questions.
Thank you. So thank you, Rebecca. It'll be